So we're on Unit 6. I told you there's about 10 that we have to get through before STAR test. There's really 11 or 12 units, but we hardly ever get to 11 and 12 because after we take the STAR test, we come back. We usually have Pi Day, have a little bit of fun with that. We have to get ready for the final exams, but you guys know that if you pass your STAR test, you don't have an exam for algebra. So even if your attendance isn't quite right, you still shouldn't have an exam. So that automatically exempts you. So the goal is to pass the STAR test, and then that keeps you from having to take an extra test here. All right, so Unit 6. Okay, so this is systems of linear equations. And if you don't have your journal with you today, we're going to take 3 pages of notes and then plus this 1 page as like a cover sheet. So you may not need this 4th page yet. You can probably wait till you actually get your spiral. But it's Unit 6, Systems of Linear Equations. And the reason they're called systems, wait till we get kind of situated so it's not so loud. The reason it's called systems is because it's more than one equation kind of working together. Okay? And I think I told you the other day when we were practicing graphing, and we were practicing switching things to y equals, that the goal of this unit is you can graph one line or you have one line and another line and you're trying to figure out where they cross. Did y'all remember me saying something about that? Okay, so that's kind of the goal. Systems mathematically are used a lot in business. If you ever think you might own your own business or you know somebody who owns their own business, a lot of times they do what's called a cost analysis or a profit analysis. And that's where you've got to figure out how much money is it going to take for me to start this business and keep this business going, and then how much money am I going to make on a regular basis, and at what point is what I make going to meet how much I've spent so that I can start making some money. Because that's kind of important to know if you're pouring your money into something. You don't want a business that never ever makes more money than you've spent, because you're losing money all the time. So they use it a lot in business. They use it in some sports, like for statistics stuff. And when people that analyze statistics, they use that kind of thing in sports. And they use them in engineering and things like that. Because you kids always ask me, when am I ever going to use this? Well, if you own your own business, you might not use it, but you'll pay somebody to use it, probably with a computer. But at least you kind of know what they're doing. They're analyzing where those graphs meet. Okay, so day 1. We do have a couple of vocabulary things to kind of take care of. This is solving systems. Oh, I can't spell. Simpsons? What am I writing? Systems, there we go. By graphing. I don't know if I can squeeze. There we go. By graphing. Solving systems by graphing. So first thing I got to tell you is what the heck is a system of equations. So, system of equations. A system of equation is simply more than one equation. It means we're looking at more than one. Now in Algebra 1, we are only going to look at 2. Later on in other math classes, there's a chance that you might look at 3 or 4 or 5. But in our class, we're only focused on 2 equations at a time. So it won't get more complicated than that. It'll stick with 2 for our systems. So the next thing you need to know is what is the solution to a system? And the solution is the point where the graphs intersect, or cross, if you want to write the word cross. The point where the graphs intersect or cross. And so before we get to cutting anything out, I'm going to show you the 3 types of solutions that we're going to have. Because there's only 3 possible ways your answer should look like. So there's 3 types of solutions. And these are all linear equations. So what does that tell you about their graph? If I say they're all linear. Their graph has to be straight. It has to be a straight line. Okay, so linear means a line. So if these are all systems of linear equations, they have to be straight lines. They're not curving, they're not taking a corner, they're not doing a U-turn, anything like that. They're all straight lines. So one type would look like this. You'd have one line and then some other line. They cross right there. This is one solution. Those are intersecting lines. And when they ask you for the answer, the solution, they're going to want that point. So like if that point is 2, 2, 5, they're going to want you to write parentheses 2, comma 5, close your parentheses. So they're going to want that point to be written out. You know, like a regular point would be. The second set are lines that would look like this. What kind of lines are those? Parallel lines. How often do those cross? They don't cross. So that means there's no solution. They never cross. You can use that little symbol that looks like that. Those are parallel lines. Now, if you write the word parallel, that's not the answer to the solution. That just describes the lines. The answer to the solution is there is no solution. Or you just do that circle with a line through it. Okay, this would be like if I'm running a business and I'm always spending exactly the amount that I'm making. I'm never really going to make money. I'm never really going to lose money. But it's just, they're just going to coincide. They're always going to be parallel. The rate of change for how much I'm spending is exactly the same as the rate of change for how much I'm making. We're never really going to get ahead. So maybe like a nonprofit or something that is, they want to spend exactly what they bring in on whatever it is. Okay, number 3 is when you have a line, and then when you look at the graph of the second line, it's that exact same line, just lays right on top. So where would those 2 things cross? If I have this line and then this line right here, where do they cross? Everywhere, right? Every single place is where they're crossing. So a lot of times they'll put all points on the line. It's much easier to write infinite or to just do the little infinity symbol. That's like all the rage with tattoos and randomness like that now. So the infinity symbol, because every single point on that line is a spot where that crosses. Right? It's exactly the same. Okay, just a thought question real quick. Could I have two solutions to a system of 2 linear equations? Is it possible to have 2 linear equations and have 2 solutions? What do y'all think? Yes, no, maybe? Okay, so if I have a straight line and another straight line, is it possible they cross in 2 places? They stay straight forever. Oh. Yeah, there's no way they can like make it where they're going to curve or do something and cross in 2 places. Here's why I'm telling you this. On things like the STAR test, how many answer choices do you usually choose from? 4. How many possible types of solutions did I just list? 3. So they've got to figure out some other random answer to throw at you. They almost always put 2. They'll ask you a question, how many solutions does this system have? And they'll list 1, none, infinitely many, or 2. And a lot of times students go, oh, there's 2 equations, there's 2 answers. And they pick 2. And it makes me want to thump them in the head when I hear them say something like that. No, there can't be two. It's impossible. The line cannot bend. The line doesn't turn. They can only cross in one spot. That's it. Okay? So don't pick two, please. Pick anything but two. Because your other three are options. They could possibly work. Even if you're not working it out, at least you know one of those is a possibility. But don't pick two. That's the only one that you know is wrong. Okay, but they're going to put that on there because they need 4 answer choices. And so they don't know what else to put, so they're going to put 2. All right, we're going to need 4 of your graphs, but 3 of them are going to go all on one page together. So I would suggest you cut out 3 in one column and then just cut out 1 from the other side, if that makes sense. And I was really nice to you OCD people and moved the arrows to the inside of the graphs. So now you don't have to try to cut around every one of those arrows, because it takes you forever. And it took me a while to figure out why those poor people were taking so long to cut out a square. But it's because they're cutting every little notchy out around every arrow. So hopefully that helps you out. So cut 3 of them out in a column, like this, and just hang on to that. That goes on the next page. And then we're going to put 1 graph down here at the bottom of this page. Okay, so we're going to do 4 examples with the graphs. I'm going to try to zoom in a little bit with these so that you can see the graphs pretty well. And our goal is to graph the 2 lines and find out where they cross. And if we can find out where they cross, that's all we have to have is that point, whatever point that is. Okay, so on graph number 1, your 2 equations are y equals 2x minus 8 and y equals negative x plus 1. So write those 2 equations down. Y equals 2x minus 8 and y equals negative x plus 1. And I'm using 2 colors so that when you're copying mine, you can understand which things go with which. And when I draw them on the graph, you'll see which one's which. You don't have to use 2 colors. This first one is super easy because they were super nice to us and went ahead and put them in y equals for us. Because that's the type of equation that's the easiest to graph from. Why?
The y-intercept?
Yes.
And the slope.
Because you already have the y-intercept, so you know where it crosses the y, that's a point. And you have the slope, so you know how to count from there. So this is one of the easiest ones to graph from. So we need to know on the first one, what is the slope number on this one? 2. It's the 2. So it's the same as 2 over 1. And the y-intercept number is negative 8. So you start out at negative 8 on the y. Go down to negative 8 and put a dot. The slope is positive, which means it's going to lean that way, up and to the right. So I need to go up 2, because the top number is up and down. The bottom number is sideways. So from that point, I'm going to go up 2 over 1. Now let me just tell you, if you are a sloppy grapher, like if your lines look like an EKG strip off of somebody's heartbeat, then I need you to do as many dots across the graph as you can. Because it's going to be really difficult to see where those two lines cross if you do a sloppy line and you can't really tell how straight it is. So it's better if you just have the dots. You can see the dots. So up 2 over 1, up 2 over 1, and you can go as far as you want. If you're using a straight edge and you're being pretty careful, you can connect the connect the dots, but even with a straight edge sometimes, if you just barely tilt it, it's going to cross in a different place sometimes than it does in others. I don't know if y'all have ever noticed that. But sometimes it's hard to see if it, like you can just barely tilt your straight edge just a little bit and it's going to mess up where it crosses the X or whatever. Okay, so that's the first line. The second line I need the same thing. Technically, what's in front of that X? A -1. So if it doesn't have a number, you're welcome to always put a 1 in there. So the slope is -1 or -1 over 1. And the y-intercept is +1. So this one starts at +1. So start right here, that's your beginning point. And it's going to lean negative, so it's leaning this way. Now I could go up and to the left, so I could go up 1 over 1 this way. But is that going to get me any closer to this line down here? No, it would be better if I go down and to the right. Because then I'll see that, oh look, they're going to cross right there. Once you know that you can tell where they cross, you just need to write the solution. So what's that point? +3 and down to -2. That's the solution. So that's where those two cross. That's all you need to know. You're done once you've figured that out. Everybody got that one? Okay, so it's pretty, if you can graph, it's pretty straightforward. It's not too hard. Now, if graphing is one of those things that you really hate to do, then you might want to buddy up with somebody who knows how to graph well. Okay, and work with them and let them kind of walk you through it. Okay, next page you're going to glue those 3 graphs down one side. So, glue these down. Get those glued down. This is going to be example 2, 3, and 4. And here's your 2 equations. 2x plus y equals 2. And x minus y equals 4. 2x plus y equals 2. And x minus y equals 4. We're going to have to switch these around to y equals before we can graph. Okay, which is why we practiced that the other day on that warm-up so much. And I'm hoping that kind of helped, like, I don't know, solidify it in your brain how to do that. What moves every single time it's in standard form? The x gets moved. So on the first one, the x moves over, the 2x. And when it moves over, it has to change signs. If it crosses this equal sign, this is like the special barrier right here. If it crosses that, it has to change signs. So right now it's positive, it's going to become negative. That's going to leave me y equals negative 2x plus whatever was there to begin with, which is 2. Everybody got that? Are y'all feeling more comfortable on how to switch it around? Okay, because I think before the break, there was a lot of people that were like, they still didn't get it. I don't know why, but just taking a break from it and letting your mind rest for a couple weeks and coming back and seeing it fresh, I think it helped a lot of people. Okay, so we're switching it around.
Question on why are you gonna change the sign?
Because technically what you're doing is you're subtracting 2x from both sides. So if I subtract it from this side to make it go away, I have to subtract it from this side also so that it becomes a negative. Okay, if it was negative here, I'd have to add it to make it go away. But the shortcut is just to move it over and change the sign. Okay? Any other questions like that? Because that's a good question. And she wasn't here when I taught that, so. Okay, what's the m number on this one?
Minus.
The minus 2, which is negative 2 over 1, if we want to make it a fraction. Which makes the b number a positive 2. So your beginning point on this one is 2. So go up to the 2 on the y, put a dot. There's your beginning point. And from there, you need it to be negative, so it needs to lean this direction. So you can either go up and to the left, or you can go down and to the right, and you're still going to hit the same line. Your up and down number is 2, so go up 2, to the left 1, like that. Or you can go back to your original dot and go down 2 to the right 1. You see how it still lines up? Either direction is okay, as long as when you go left or right, you go the correct direction. Otherwise, you end up with a V, and that's not what you need, or an arrow-looking thing. You need it to be a straight line. Okay, so the second equation, again, the x has to move over. When it changes, it's going to change to a negative because it's a positive right now. This y is already negative, so it stays negative. You can't change it yet. So negative y equals negative x plus whatever was already there, which is 4. And I'm not allowed to have a negative y. I can change all the signs. Now that's the same thing as dividing by negative 1. But I taught you that the shortcut for that is when you divide by negative 1, it just changes every single sign there. So that changes this to y equals positive x minus 4. What's my slope on this one? What number's in front of that x? 1. So my slope is 1, or 1 over 1. What's my y-intercept? Negative 4, right? So this one starts at the negative 4 on the y, so go down 4, put a dot, and it's going to be positive, and it's going to go up 1 over 1. I could have gone down 1 to the left 1, but why was it better to go up?
Because the line is.
Because I'm trying to get to this line. If I go down, I'm never going to reach that line, so it's better to go up. And you can see they cross right there. Solution is 2, negative 2. That's your answer. Okay, 2 more of these, and then we'll do that back page, and it's really fast and easy, so. These are a little more time consuming just because you have to draw the graphs and whatever. Alright, so number 3. Does everybody have that written down? You got it? Yes? Okay. Alright, so number 3, your equations. Your first one's x minus 3y equals 6. And your second one is y equals 1/3 x plus 1. Okay, they were a little nice to us on this one, not completely nice, but a little. Because one of them's already switched to y equals, right? So I only have to really mess with this one. And then we can graph. So let's fix this first one. Let's move the x first. This becomes negative 3y equals negative x plus 6. Now what's in front of that x?
1.
A negative 1. So put the 1 there. Because I'm about to divide by a number, and it makes a whole lot more sense if it's 1 over the 3 than if it's just an x over the 3. Right? That usually registers more with you about what you're supposed to do. So divide everything by the number in front of y. This becomes 1y equals 1/3 x minus 2. So for that line, what's my slope? 1/3. And what's my y-intercept? Negative 2. So it starts at the negative 2. Your beginning point is negative 2. Put a dot there. It's a positive slope, so it's going to lean this way. So you can go up 1 over 3. 1, 2, 3. Or you can go back to your original beginning point and go down 1 to the left 3, and it's still going to be the same line.
Is this the solution?
Maybe. Okay, so this other equation we don't have to switch. It's already done for us. All we need to know is what is the m, what is the b. So m is 1/3, b is 1. And if you think about the lessons that I've taught you before, if they have the exact same slope, what kind of lines are those? Parallel. If their slope is, the slant is exactly the same, those would have to be parallel lines, right? Does that make sense to y'all? So if they're parallel lines, you kind of already know what the answer is, but we're going to go ahead and graph it. This one crosses at the 1. That's your beginning point. And from there, you're going to go up 1 over 3, just like the one below it. Okay. So there's my 2 lines. Obviously, after graphing those, you can tell, even though I didn't do a very good job with my straight edge, but you can tell they're parallel, right? So what would be the answer to the solution on this?
No solution.
No solution. Or you could do that little sign like that. Don't write parallel lines because that just tells me what kind of lines they are. That does not tell me the answer to the solution. You have to put no solution, okay? Alright, last one, like this. And if you know me and the way I teach very well, you probably already know what the answer is going to be on this one, but we're going to graph it. Okay, so your first equation is 2x minus y equals 1. And your second equation is negative 3y equals negative 6x plus 3. 2x minus y equals 1. Negative 3y equals negative 6x plus 3 is the other one. So let's switch the first one around. What gets moved first? The x moves, and it becomes negative. So I'm left with negative y equals negative 2x plus whatever was already there, which is 1. And I'm not allowed to have a negative y. So the shortcut is switch all the signs. So switch this negative to positive, switch this negative to positive, switch that positive to negative. So there's my equation. What's the m and what's the b on this one? 2 or 2 over 1 and negative 1 minus 1. So this one starts out at the negative 1, right down here. And it's positive 2, so you go up 2 to the right 1. Like that. Or you could go down 2 to the left 1. It would be the same line. Okay, on the second equation, they've already moved the x for you, but you still have to take care of one thing. What do we have to do? We need to get rid of that negative 3. So we're going to divide every single thing there by negative 3. That gives me 1y equals a negative over a negative becomes a positive, and 6 divided by 3 is 2x. And then this one becomes a negative 1. What do you notice about that one versus that one? They're exactly the same, right? So if I was going to graph it, which is kind of pointless for me to draw it again, but if I was going to graph it, it would be right on top of that one. So this is all points on the line, or you can do the little infinity, or you can write infinite, or whatever you want to write. That's kind of along those lines. You can't necessarily put all real numbers, because that's not always exactly true. But put all points on the line, infinitely many, I think is one that they like to use on like star tests and stuff. Anything that kind of shows that you know that it's crossing everywhere. Okay, last part to cut out. I just cut this paper out like this. So we're just going to glue this whole thing down on the next page. So just kind of cut around the outside edges of it. Leave the words at the top so that you'll know what the heck we're doing whenever you go back and look at this. Because if you don't, then you won't remember what the instructions were. And that way you don't have to write it down. So it just kind of looks like that. And go ahead and get your calculators kind of out because we're going to use them on part of this. I'm going to show you ways to use your calculators to figure these out. And then I'm also going to show you how to figure it out without them. Okay, so it's asking you to look at these two equations and decide if the point that they give you is the possible solution. Okay, they didn't give you a graph though, so they're not asking you to graph them, but they're wanting you to figure out whether that's the solution to those equations. A couple ways you can do that, and I'm going to show you the calculator first, because the first one's already in y equals. So since these two are already in y equals, it makes sense to use y equals on the calculator. Anytime you have problems where it looks like everything's in y equals, that might be a good place to start, is your calculator. Especially in a testing situation where you're using like multiple choice answers, because you know one of those answers has to work. But what I want you to do right now is go to y equals on your calculator. And they've already switched these around to y equals, so I don't have to fix anything, which is why I'm using the calculator on this. It doesn't require a whole lot of work or a whole lot of brain power, so this is one I can kind of save some power and use on one of these others. So we're going to type in both of them. So type in 1/2, which is 1 divided by 2, x plus 2. That's the first one. 1/2 x plus 2. So it should look like that. 1 divided by 2, x plus 2. If you hit enter, it should pop down to the second one. So your cursor should be blinking beside the y2. Everybody kind of following me so far? Okay, so when you get to the second one, type in the second one, x minus 2. And, I mean, y'all see there's tons of y things there. You could put a whole bunch of them. But we're only doing 2 because we don't want to stress out. We just want those 2. All right, everybody got that? I need to figure out if this point, 8,6, is on both of those lines. What do I look at that gives me some points that I can see? Second graph. If I look at the table, I can see points, right? If I hit graph, it's just going to show me a picture of the lines. Well, then I get to try to guess if that really is 8,6 where they're crossing, and it may or may not be. So hit second graph. So I want you to see what happens. Y'all see how there's 3 columns? Okay, so what they've done is they've got where x is 0 on the first line, it's 2, so that first line has 0, 2. The second line is negative 2, so the second line is 0, negative 2. And then at 1, x equals 1, it's 1 comma 2.5 for the first line. But on the second line, it's 1 comma negative 1. Okay, we need to look at 8 comma 6. And if it's on both lines, they should match. So go down to 8. And do you see how it says 8 and then 6 and then 6? That means both those lines have 8, 6, and then the other one has 8, 6. If they both have that point, that has to be where they cross. The only way both those lines could have the same point if it's that one point right there in the middle where they both cross, right? There's no way else for them to have the same point because they're 2 totally different lines and they don't curve. So yes, 8, 6 works for that one. Done. Easy enough? Okay, so if it's already in y equals, that's a great way to do it. The second one we're going to do without using y equals. The second one I'm going to show you on the calculator. So, on the regular calculator. So hit second, and then hit the mode button that's right beside it so that you go back to just the normal everyday calculator screen. Because you can kind of do this on any calculator. Okay, so I've got these 2 equations. I've got this point. This is an x, this is a y. What if I just plug the numbers in and see if they work? They have to work for both of them, though. So this first one is 2 parentheses minus parentheses, and it has to equal 1. So 2 times the x number, which is 2, minus negative 1, has to equal 1. So type in your calculator, 2 parentheses 2, minus parentheses negative 1. So type that in just like that, 2 parentheses 2, minus a negative 1. Hit enter and see if you get 1. No, you get 5. So it doesn't work for that first one. If it doesn't work for the first one, there is no reason for you to do the second one. Because the only way that can be the point that you're looking for is if it works for both. So that's a big no. All right, number 7. You could do either way I just showed you. You could switch it around to y equals, put them in the calculator that way. Or you could just plug in the x's and the y's. Now this one's a little bit different because look at this second one. It has y on one side and x on the other. So you would have to plug in the 4 here and do 4 minus 4. What's 4 minus 4? Is 0 going to match 2 times negative 1? No, right? There's no way that's going to work. So if I just look at that logically, I already know. I don't even have to worry about the top one. These are not super hard. Use your common sense. kind of plug them in and see if this input number will get you that output number on both of those equations. Okay, the last one, simply because the first one's already in y equals, my suggestion, my line of thinking would be to switch the second one and use y equals. But I have a lot of students would just rather plug them in. It doesn't matter to me which one you do. But what I would probably do is switch this around to negative y equals negative 2x plus 4, and then switch all the signs. And then type this and this in y equals and look and see if that works. So go back to y equals and try it that way. And all you have to do is hit clear on each one of those, the y1 and y2 when you get there. So 3x minus 2 is the first one, 2x, not plus, minus 4 is the second one. So you're going to type those in. I don't know if you can see it like that. 3x minus 2 and 2x minus 4. And you're looking at the table to see at negative 2, do they have a matching point? And is it negative 8? Yes or no? Yes, it matches. Okay, so even if you don't have this calculator at home, you can still do the plugging in thing with a regular calculator. Or by, like this one up here on number 7, I just did in my head. Because 4 minus 4 is 0. And I knew that 2 times negative 1, unless that other answer is 0, it's not going to work. Okay, so on your assignment, before I turn off this tape, because I want to make sure everybody hears this, a couple things I want you to check on your assignment and be careful about. On this first part and on the next part down here, not this in the middle. Well, it says, tell me if it has one solution, no solutions, or infinitely many solutions. Pick one of those 3. But if it has one solution, not only do you tell me it has one solution, but you tell me the point. Okay? So, obviously you're not going to write all the points if it's infinitely many, because that would take an infinite amount of time, and we don't have that. So, the only one you have to write the point is if they're actually cross. At one point, if it's one solution, you have to tell me the point, or else you'll miss part of it. So be careful with that. That's on this part, and that's on down here, number 6 on. The homework looks really long. It only has like 12 questions, 13 questions. It's just because these graphs are so big and they take up a lot of room. These box things right here, they were stressing some of my students out. That's just if you want to use it to switch this around to y equals, you can. You don't have to use those boxes. I don't care where you write your work. That's just how it was. Yes, you have to graph them and show me where they cross. Now, obviously, if it's the same line, I don't expect you to graph it twice. But you have to show the graph because the graph is part of your grade. So make sure you do that.